Hello, Arati madam.
Yes, sir. Join.
I will hand over to you, madam. Just a minute.
Okay.
Good morning to all of you. This is Dr. G.P. Pawan, AICTE convener. Today's topic is on day 4, the machine learning with IoT. So our honorable speaker is today Dr. K. Tippeswamy, Professor and Program Coordinator, Department of Computer Science and Engineering, Center of PG Studies, Vishwaraya Technological University, Mysore, Karnataka. So today, the sir is taking on, especially on the topic of the machine learning with IoT under the heading of AICTE heading. So explainable artificial intelligence and machine learning, that is for solving learning problems using the TensorFlow. This is the AICTE heading of. So I would like to invite and welcome to the SITAMS Engineering College Autonomous NAC and be accredited for computer science and engineering department. I will just hand over to Arti madam to give the profile on honorable resource person Dr. K. Tippeswamy.
Thank you, sir. This
Arti
is
madam,
Dr.
please take
Aarti.
over.
Yes, sir. This is Dr. Aarti, Associate Professor from Department of CSC. I'm very happy and very proud to introduce today's resource person, Dr. K. Tippeswamy, sir, who received his doctorate from Department of CSC, Jawaharlal Nehru Technological University, Anantapur. Sir has received his ME CSC from University Vishweshwaraya College of Engineering and Bangalore, and sir has completed BE CSC from University BDT College of Engineering. He is currently working as professor and head in Department of CSC, Vishweshwaraya Technological University, PG Center, Mysore, Karnataka. His major research areas are data mining and knowledge discovery, big data, information retrieval, and cloud computing. He is having 18 years of teaching experience and 3 years of research experience. He has published more than 1,000 papers, which includes international journals, international conferences, and national conferences. And Sir has organized 2 national and 1 international conference successfully. And Sir has authored a book on unstructured data classification in international publisher Eliva Press. Currently, he is a member of BOA Bangalore University, AICTE VTU Steering Committee member, VTU, member of BOE for Vishweshwaraya Technological University, Bangalore University, Manonmaniam Sundaranar University, JNTU University, Hyderabad, and Mangalore University. He is a member convener in LIC Committee VTU and advisory committee member in Devraj University, member UGC Project Enhancement Committee, Mangalore University, etc. He is a life member of ISTE and CSI and International Association of Engineers. He is serving as a reviewer for the International Journal Bioinformatics and Data Mining. We are so happy to have such an eminent person for this STTP session, sir. Thank you for accepting our invitation. We are very happy. Once again, we welcome you as a resource person for this STTP. Now I request Dr. Tippeswamy, sir, to take over the session.
Yeah, good morning.
Good morning, sir.
I am very much thankful to Aarti madam for giving a brief introduction of myself. And I want to extend my thanks to SITAMS Engineering College, Dr. Pawan, and AICTE, as well as authorities of VTU for giving an opportunity to share my thoughts in the machine learning with IoT in this auspicious occasion. Myself, Dr. K. Tippeswamy, I think already Aarti madam has introduced in a brief. Today, I want to take up this session, start with machine learning with IoT. So all of you know that the machine learning is trending, and also it is very much necessary for today's scenario. And how this machine learning is going to be embedded with IoT, because till now we have we have working machine learning independently and IoT independently, and we have come across many IoT applications independently. But now the current scenario is how to embed this IoT, Internet of Things, along with machine learning applications. That's what today's topic. I think all of you agree with me. Okay, now start with an what is machine learning? I think you know the learning is a process by which the system improves performance from experience. Uh, as of we know, the system understands only the data, right? But how, based on the data, the machine is going to give you a knowledge. Is it the machine is going to give this knowledge based on self-learning, or supervised learning, or unsupervised learning, or self-supervised learning? This is what the machine learning all about. Then machine learning is a study of algorithms that improves their performance at some task with experience, that is PTE, performance, task and experience. A well defined learning task is given by the PTE. Any machine learning algorithm, what it does, first it has to train, then do performance, then task, then give results based on the experience. If I want to give a simple example of machine learning task and experience, how the budding child is going to experience the real world, then act according to that. That is exactly what machine learning will do. First it understands, and then do performance, then do task. That's what all about PTE. Then what is the programming comparisons? Here is that the traditional programming, what we do, we supply data and program code. Based on the program code, it start executing with available data. The computer will do performance, and finally it gives the result. I think you agree with me what the traditional programming will do. Then what is this machine learning programming will do? It accepts data and output which is comes from the learning experience, then it gives its own programming code. This is what the machine learning. I think all of you accept with me. Yeah. So data and output, where it comes in this output? But see, earlier the traditional programming, we have combination of data and programming will give output. But in the machine learning, we have a combination of data and output, then it gives this program. It is called the self-supervising. So the output is a predefined data. For example, if you take rainfall forecasting, what are the parameters are there to do forecasting of rain? Wind speed, wind direction, temperature, pressure and humidity. If you take these 5 parameters, we can predict in next 24 hours whether the rain is going to be occur or not. So every minute, every second data is going to start recording based on these 5 parameters. I think you know that in the Hyderabad Kalpakam power station, there is a recording station is there. Every minute, every second data is going to be recorded. Based on this data, that data itself is called an output. So along with the data and the output, if you provide in the machine learning algorithm, it gives you a program. So that is what the program comparison. All of you agree with me? Yeah. Then when do we use machine learning? Which are the areas where machine learning is going to be used? Look at that first statement. Human expertise does not exist. So the some places where the human intervention is not possible. Example is in Mars. Yeah, till now, the human is not able to enter to the Mars, but our missions are entered into the Mars and study the environment of Mars. But how is it the only the output and data is enough for entering to the Mars? And is it act upon its own? Yeah, it's required act upon its own. The machine has to act upon its own. It has to learn the environment. Based on the environment, it has to act according to that. Otherwise, if you instruct or if you give only instruction, the machine will do according to that instruction what we have given. But we don't know what is the environmental status in the Mars. That's what. So Mars is going to that machine learning that is machine is going to learn the environment, then act according to that. So that's what we need the machine learning when the place where the human intervention is not possible. Agree with me? Yes. Then what is this second point? Human cannot explain their expertise. Sometime the speech recognition, if you take an example, you know the humans speech are differ from area to area, then continental wise, then their accent and their speech ability. Sometimes the speech is going to be very clear, sometimes it is going to be very moderate, and sometimes it is going to be very low. But even though we can not, the human cannot understand where some speeches are very low. In that case, our missions are going to be help you to recognize this speech, especially in the field of secret agencies, or in the field of defense, or in the field of telecom sector. This speech recognition system, the missions are more helpful than the human expertise. So machine learning will explain, will help you in this direction, recognizing the speech. The third one is models must be customized and personalized medicine. Here, see, the any expert doctor, without the help of machine today, he cannot able to predict what is the remedial and what is the cause, what is the disease which occurs for the body. I think you agree with me. Today, if you go to a normal disease to the doctor, the first suggestion is go to MRI scan, go to blood reports, many things. Why? Why? Because the doctors completely depend on machine learning tool. That's what it is. Personalized medicine. Agree with me? Today, I think most sophisticated doctors also going to be completely depend on the machine learning tools. The next one is models are based on huge amount of data, that is genomics. Actually geo informations are going to be in the form of huge amount of data is going to be collected, and that too data is in the form of unstructured. I think you know that what is meant by unstructured. This is a combination of data which includes textual, video, audio, and graphics. If it in the form of huge amount of data with unstructured, it is very difficult to classify the data by the human expertise. So that the machine learning tools are going to be very much helpful for classification of this geomanics data and understand this data and classify, then convert this data into human usable format. Understand? So see, look at that. These using these 4 different usages, we can guess that how machine learning tools are very much helpful in today's life. Human expertise does not exist in the Mars, but still the machines are going to be extract data in the Mars. The next one is recognizing your speech based on the machine learning tools. The customized medicine, because different bodies are having different kind of disease, so it has to identify the disease based on their body structures and diseases. Then the last one is geometric data. That's what I told you, that the combination of heterogeneous data is going to be classified into the homogeneous. Now, what is this designing a learning system? How to design learning system? The first point what we can see is choose the training experience. Why need machine learning tools need a training? Is it necessary? Of course, it is very much necessary. Why? Because any new things brings to the mind of any person, you cannot able to recognize that. Why? Because you are not expertise, he has not trained with that object. But once the object is trained with your mind, next time if you look at that object, immediately you will recognize. Why? Because already it has reposited in your mind. The same way, your any designing of learning system, it has to train first. Then next time if you supply the same amount of data, same kind of output, immediately it recognizes and creates a program. Agree with me? Yes. Okay. In what is this training experience? How to do this training experience? Okay. Take an example of same weather forecasting or rain forecasting. I tell you the different parameters. That is wind speed, wind direction, temperature, pressure, and humidity. If I supply these 5 parameters into the learning system, what it does first, it has to do process or performance. And what is the amount of data you need to supply? You need to supply at least 2 to 3 years data of these 5 parameters. So your learning system will learn every second data and it creates its own program. Then what you do, next time after the completion of the training process, the system is learned now. Learned system. Learning is different, learned is different. Now the system is ready for your acceptance of your input. So once if you apply submit today's and today current status or current data of these 5 parameters, immediately it recognizes the previous experience, that is previous training, and it gives result up to 98%. It has proved that it gives 98% result in this production. So that's what this training experience. Are you agree with me, everyone? Yes. Now, what is the second one? Choose exactly what is to be learned. That is target function. Different learning systems are going to be accept for different scenario. The forecasting is different. Your prediction of a disease is different. Your prediction of object is different, like that, because it is completely maybe the system is learning system is one, but depend on the parameter. That's what the data, the output, it's create a program. If I provide data with 5 parameters of output, that is prediction, then it gives rain forecasting. The same time, if you give body details like prediction of disease, you need to give data of your body details along with the output. Then it gives create a program and it gives accurate result of what is exactly happened in your body and what is exactly the disease is going to be, the level, in which level the disease is going to be there. So that's what you need to choose exactly what has to learn. Then according to that, the system is going to be acts. That's what is machine learning, we call it as. It has to segregate the data, it has to simplify the data, it has to classify the data and act according to that. Then only it is going to be a perfect machine learning system. Then choose how to represent the target function. Here, suppose if you take an example of a disease in your body, is it the entire body is going to be scans? Of course, it is going to be scans entire data, the entire body. But if you have a pain or if you have a disease, in your eye, the machine should not look at the nose, should not look at the skin. It has to target the eye, then it has to identify the disease in eye. So that's what we need. That's to do that, your machine learning system should learn in such a way that it has to identify what is the target function. Agree with me? So this is what we call it as a target function. Your machine learning system should learn and should create a program in such a way that it has to target the system which is instructed by the admin or a user. Next is what? Choose a learning algorithm to infer the target function from the experience. Of course, after getting an experience, definitely the algorithm will target your function or infer the target function with a particular experience. So that is the learning machine is going to be use more accuracy if it is able to target the function using infer. Look at this diagram. Start with an environment and experience, and it collects the data. So what we do give first, we give a training data set and learner. First it learns, then creates a knowledge, that is called program. Then if you give a testing data, it give performance. So this is what a simple analogy of learning system. Yes, agree with me? I think all of you. Yeah. We proceed to the next slide. What are the types of learning? If you understand these types of learning, I'll give a simple analogy with these types of learning. A budding kid, I take an example. First, it needs a supervised learning. What is this called supervised learning? First, the kid has to understand how to walk. Means understand means first it has to try to walk. And during that time, many times the kid is going to fall and start again standing, then fall, then stand, then slowly it start walking. So in this process, how many times the failures are going to be happen? How many times the failures are going to be occur? That is called the supervised learning. It means that the number of iterations are required to learn that. That is what supervised learning. We need to provide the data for supervised learning. Then we can get an desired output, that is labels. We'll see in detail in the next slides. Next, the next point is unsupervised learning. Here, training data set is not there. Means without a desired output, the learning algorithm will give performance. That is called unsupervised learning. Means once the program is created, the program itself is going to generate the data. For this, I want to share a small example of a film called Air Force One. If anybody saw this movie, there how the after hijacking the flight acts itself is an unsupervised learning. Means based on the environmental data, the flight is going to be acts according to that. In one point of time, the flight is going to be flips in that Air Force One movie. Why? Because why it is flips? Because the target object is coming to in front of the flight. It means the enemies are fired a missile towards the flight. To escape that missile, the flight flips. How it flips? Anybody has given instructions? No, only program. It is programmed in such a way that it has to learn on its own. That is called the unsupervised learning. I think you agree with me. Next is what? Semi-supervised. In this case, some amount of data is going to be supplied by the system and some amount of data is going to be supplied by the human. Here, the example is prediction of your disease, body disease. How? Based on the machine learning algorithm data and the doctor's expertise, he is going to be predict the disease up to 95%. Still, they cannot able to achieve 100%. Why? Because some errors are going to be there even with the data set as well as from the doctor's decision. So in this case, semi-supervised learning will help in this scenario. So finally, we are in reinforcement algorithm learning. It rewards from the sequence of actions. What is this reinforcement? It is going to be a continuous learning system, supervised system as well as semi-supervised is going to be continuous. In some point of time, the learning system will start with supervised learning, and after some point of time, it is going to be converted into unsupervised and semi-supervised also. That's what it is. A sequence of actions are going to be taking place in the reinforcement learning. Agree with me? These are the different types of learning system. Come to the supervised learning, how the machine is going to be learns with a problem. Look at that example. Here, the learn through examples of which we know the desired output. Yeah, of course, there is a question is this a cat or dog? If you look at the naked eye, we can easily identify what it is based on their facial structure or based on their environmental variables or environmental parameters. Anybody can guess it. But how the machine is going to be identifies this? Because the machine has to learn the objects of cat and dog. Then only it predicts. And it predicts exactly either it is cat or dog. There is no fuzzy here. And are these emails are spam or not? Exactly, it has to give either this email is a spam or not. The email is not a spam. And the predict the market values of houses given in square meters, number of rooms, neighborhood, etc. These are the simple examples of supervised learning. How this market is going to be predicts the houses. And today we have a number of social media websites available for market basket values. How in any particular area you want to rent or lease or buy a property or house property, what do you do first? You go to the many websites which is available in the internet, then you predict and you can compare, and based on this comparison ultimately you're going to come to the conclusion that maybe in this area this is what the price for renting, leasing or buying. So is it this prediction is correct? If it is not, how I can accurately identifies what is the house values of this in this area, market value of these houses in this area. So one way is identify based on the social media. The other way you can supply this data in the machine learning. Then you can you may expect the predicted results. I think you agree with me how this supervised learning is going to helps the people to get a strategic decision. So finally, by buying a house, based on these two kind of predictions, you come to conclude that maybe in this area plus or minus this is what the amount is required to invest. So then finally you're going to invest in the based on this prediction. So supervised learning helps you to take a strategic decisions. Here, what is this discrete and continuous? In this classification, the variables are based on the variables. You can discrete means exactly you can tell that either this is going to fall in the classification of both, like so there is the blue dots and green dots are there. You can tell exactly that either it is a cat or a dog, or either it falls in a blue dots or it falls in the green dots. It's not continuous because your output must be very clear, either 0 or 1, either true or false. That is called discrete. But to come to the regression, it is going to be continuous, where some applications like pricing of commodities or the temperature. Is it temperature is going to be discrete? Not, you cannot. If in the second, what is the temperature is going to be differs in another second, and the price also going to be vary in every moment. So in this case, the prediction is the accuracy of classification and identifying the output is 100% in discrete, but below 100% in continuous. Why? Because the prediction is going to be somewhat difficult in the continuous regression outputs. I think agree with me, all everyone? Yeah. I think classification and regression, you understand what is that? In the classification, the output is going to be narrow, that is 1 or either 0 or 1. But in the regression, it is going to be a fuzzy. Next is unsupervised learning. What is this unsupervised learning? I think already I explained with an example of flight, how it understands its data based on the environmental changes, and also the Mars vehicle, how it understands the data based on the surrounding parameters. In this case, there is no desired output. Learning something about the data and latent the relationships. It means that it has to identify the data as well as output based on the surroundings, and it has to act according to that. If it is fails to act according to that, the learning is not proper for these machines. Example, I have a photos and want to put them in a 20 groups. But these photos are going to be heterogeneous. Your machine learning algorithm should able to classify these photos into 20 groups with based on the identical. Just like a geoinformatic data. Then I want to find the anomalies in the credit card usage patterns of my customers. It is very challenges and tedious job for identifying the credit card usage in the patterns of my customer, because customers' tastes are different from person to person. Some persons use their credit card only for the household purpose, or only for the emergency, or only for the prescribed, or only for during certain amount of time. It means that what I want to tell you, a salaried person, sometimes he will not use this credit card up to first 20th of a particular month. Can you guess why? Why? Because first 20th, the salary is going to be happen at first, and he may spend this amount up to 20th of every month. After 20th, he needs some loan, so he maybe use this credit card during that time. Majority of time, this credit card going to be used during this period. So bank who means guess that some people are using this credit card mostly during these 10 days. So they're going to target these kind of people for selling their credit cards. And some people start using this credit card for every transactions. Since start from first day of the month. Why? Because you don't want to handle the cash, or you don't want to handle these debit cards. Ultimately, you start using this credit card, but the percentage may be less. So how to predict this? Your unsupervised learning algorithm experience or learning algorithms helps you to classify these kind of people and target these people for selling their items. Is it helpful for the banks? Definitely, it is going to be helpful for the banks to identify the anomalies, and also credit card uses or uses patterns are also going to be identifies. Later, the banks are going to be identify the list of list of customers who are used for different patterns, and to take the list of most used customers in the different patterns and target based on these patterns or usages. So they can improve their business based on the classification in unsupervised learning. Yes, I think agree with me regarding this unsupervised learnings. Yeah. What is types of machine learning problems? Here, useful for learning structures in data, that is clustering, hidden correlation, and reduce dimensionality, etc. What is this clustering? We have talked about classification. The classification is the heterogeneous of the data is going to be classified into homogeneous format. Then how the clusters are going to be helpful for classification of the data? Here, what is hidden correlations? Suppose while using the credit card system, we know that only we can pay what we spend. Is it so? No. The banks are going to charge you based on your usage. If you use the credit card system for 50 days, there is no hidden charges. After 50 days, there must be a interest along with the bank charges. That is what the hidden correlations. So to do that, the clustering, your algorithm should be structured or should be learned or should be created in such a way that it has to handle all these anomalies and reduce the dimensionality reductions. Look at that diagram where the left hand side we have a homogeneous kind of data set, but to look at the right hand side, there is a group of 3 different clusters. Here maybe a red line refers to your loan amount with respect to credit card, the blue line is refers to the interest, and the the green line, the green dots are going to refers your hidden charges. Did you agree with me? But is it is it visible in the right hand side while applying your loan? No, it is not visible. So this is what we can call as identify the dimensional reduction as well as hidden correlations. Agree with me? Yeah, that is what this unsupervised learning helps you to identify all these kind of anomalies. Come to the reinforcement. What is this reinforcement? It is a continuous. An agent interact with an environment and watches the result of interaction. What this diagram, what is look at that screen, what it identifies? Yeah, the dog expects that in what time I can catch this. It waits for the turn and right situation to catch this. Is it so? That's what. The algorithm waits for the right data and output, then it creates a program to execute the jobs. Here, the environment gives a feedback via positive or negative reward signals. If it is a negative reward signal, definitely it waits for the moment, and once it converts into positive signals, then immediately it acts upon that. That is what this reinforcement. It means that it is continuous watching, then act to get a good accurate results. Agree with me now? Yeah, these three types are very much essential for creating a machine learning algorithms. Out next is what the steps to solve machine learning problems. Which are the steps? See, data gathering. For any machine learning problems, the data is very much necessary. How much amount of good data you have, that much accuracy we can expect from the machine learning algorithms. So more and more data gather is very much essential for getting a good machine learning algorithms. Then collect the data from the various sources. Yeah, today gathering data is very simple, but it is completely heterogeneous data. That's what the big data arises today, because big data can handle heterogeneous data, and in terms of huge amount of data in the form of either terabytes or terabytes also. The next step is data processing. Once the data is gathered, your next thing is to process the data. Is it the raw data is going to be useful for processing? Not at all. You need to clean the data to have homogeneity. First, you should clean the data with the different techniques that we can learn later slides. The next step is future engineering. What we can use for what kind of data can be used, making use of data for more useful, that you need to identify. That is what futuring the data. Then come to the algorithm selection and training. The selecting the right machine learning algorithm is very much essential for this selection of training and algorithm. So finally, taking a machine making predictions. So based on the data, experience, and finally predict the data with the evaluated model. So this is what the simple steps of solving machine learning problems. We'll go to in detail how the data is going to be gathering. Might be depend on the human work. I think everybody has experienced that. Today, without creating a data, nothing will happen. That is the scenario in today's, because every day, every minute, whatever we do transaction, either in the financial sector or in the education sector, or in the grocery market or in the supermarket, wherever you go, the data generates. So most of the data generated by the human work, that is manual labeling of supervised learning, domain knowledge, maybe even experts, and may come from the free sort of the machine translations. If you take an example, if you send a vehicle or launch your satellite, once it start launching, it start recording the data and send it back to the server in tons of data. That is going to be a heterogeneous amount of data. This very challenging is classification, clustering of the data is very challenging, especially in the machine translated data. Even in an X-ray machine, take an example, simple example, the MRI X-ray machine. Actually, you want some portion of the body to extract, but how the machines are then it translates into data. That data it gives you in terms of um, complete set, but you need to identify what you need from out of this machine translated data. So in such a, if you take an analogy, you need 1% data, but give machine translates you 100% of data. Out of that, getting 1% is very difficult again. Then the more the better. It means that whatever the data you have a large amount of data, then your accuracy is going to be more. Why? Because see, if you take an example of weather forecasting, if you take a 1 year weather, your result may be accuracy may be 70 to 75%. If you 2 years data, it may be 80%. If you take 10 years data, your accuracy must be 98%. It proves. Why? Because the more the better. It means that your learning system should learn more and more. Then it gives better and better results. That's what the meaning of this. Then the quantity and quality of data dedicates the model accuracy. What is this quantity and quality? Okay, if the more of data with less quantity, is it worth? No. The quantity and quality must be maintained for getting a good accuracy or accurate result. Suppose I talk about machine translation data. In this data, maybe the data in the huge quantity, but quality, is it there? No, because wanted data, unwanted data, and all heterogeneity data is going to be reposited in this scenario. But we need only the data which requires for the target functions. That we need. That is called quality data. So more data and quality, more quality data is required for getting a good accuracy. So finally, data gathering must be depend on quantity and quality. Did you agree with me? Yeah. Now proceed to the next, that is data processing. Okay, the collection is over. The data collection is over from the different scenario, like different sources, either from the human source or from the machine translated or from the other sources. But the processing of this data is very much challenging, and it needs many parameters. That is missing values you need to fill up, outlier you to remove outliers, bad encountering for text, wrongly labeled examples, and biased data. What is this missing value? First, for example, collecting of your personal information in any where, either in the hospital or in the grocery shop or in wherever you go, either in the online entries. Sometimes we miss, taking example of address 1 and 2, but somebody will have street address, somebody will have not street address will not be there. Then in this case, the street address may miss in this during this occasion. But while accessing this data, if you miss 1 or 2 parameters, the accuracy is going to be reduces. Why? Because the learning algorithm, I'll access the data based on the full length data. If it is missing 1 or 2 value, automatically your accuracy is going to be decreases. That's what this. The complete data will have not missing values in any of the data sets. Then only the data is going to be full length data. Otherwise, the data is a non-quality data. Means there are 2 terms here: qualitative data and non-qualitative data. If it is a missing values or occurs, then it is not non-quantitative qualitative data. Then come to the outliers. What is this outliers? For example, in a recording, during recording time, only the voice which is required, either in the singer or in the politician who speaks something, his voice is required. Is it only the machine is going to be recorded only the data or only the voice which is given by the singer or a politician? No, along with the environmental data, that is unsupervised data, is also going to be records. But you need that data? No, we don't want that. We need only the singer voice, but the surrounding voice also get recorded. Then how to remove this outlier? There is some algorithms to remove that outlier and clean the data. using removing these outliers. Then only it is a qualitative data. Then bad encountering of text. While doing the text, sometimes spelling mistakes or sometimes the grammatical mistakes is going to be happening. Then you what to do? You need to encounter this bad text. Then only the data is going to be a qualitative data. And wrongly labeled examples. Suppose while in the supermarket, while doing labeling for different fruits, for the apple, if you label with orange, will you accept? The customer will accept? Not possible. That is what labeling of data is very much essential. In the prediction of rain forecasting, the label of individual parameters are very much necessary. Then only the learning algorithm will understand based on the labeling of data. Right. So the labeling of data is very much essential for getting a good predictions from the learning algorithms. Then come to the biased data. What is this biased data? Sometimes we neglect the data and we bias and go to the next data for processing. But if we sometime in this case, many times the algorithm will not able to understand what is this the biased data, because the learning in the learning process it needs a complete data set, then only it learns. If you take a simple example of again the budding kid, the kid will not able to experience while learning, while walking with a different set of ground level, then the kid will not learn for he is learning only the walking in the safe surface. If you even though the kid knows how to walk, but if you leave that kid for the different surface level, he cannot able to walk. It means that the machine fails there because of not able to learn properly with the different data sets or different in this case different surface levels. Agree with me? That is called we are we able to learn the kid with learning walking experience, but he cannot able to walk in the different environment or different floor set. Then the machine fails. Even though he knows how to walk, but he cannot able to walk. The purpose is not served because of biasing of data, biasing of learning system. Then come to how to come out with this different wrongly stated data by fixing and removing data. If it is a missing value, fix it. If it is outlier, remove. And if it is a bad encoding, then remove it. And wrongly labeled, make it proper, fix it. Then biased data, fix it. And if it is required, you remove the biased data with more bad data. That's what many more samples of one class than the rest. Now, look at this example. There is an apple, but out of that green apple, one red apple is there. Is it homogeneous? No, it is no, not homogeneous. Even in the graph also it explains that out of many in the fall in one line, but the one object is fall in the other line. It states that biasing. So what you have to do? You need to remove that. Then it is going to be a reset of data. This is way how we need to fix and remove the data, and finally it becomes the good data for further proceedings. If you provide quality data, then we will expect good accuracy. That's what the reason why we need to process this data. Agree with me, all of you? Yeah, we'll proceed to the next slide. What is this future engineering? A future is an individual measurable property of phenomenon being observed. There is an example in the right hand side, you see, buy these drugs from pharmacy. Now, what is the feature engineering? We are missing data is going to be filled up here, where the second, the third, and wherever the missing data is there, that you need to fill up with the feature engineering. Then only the data is going to be complete data. The output in are represented by a set of features, and sometimes this may be a guess. It's not 100% remove fixing of data in this example, but it may reaches up to 90 to 95%. Why? Because it classifies the spam emails. Features could be number of words that have been in this case like this. Then in the language email like English and Spanish, and the number of emojis based on the different data set. Either it is emojis, or in the numbering, or in the text, or in the character. The feature engine will helps you to replace this data with a proper data sets. So that's what how the feature engineering will helps you to make a clear and processed data for future usage. Agree with me? Yeah. Next, go to the another slide. So till now, we have understood that how the data is going to be collected for machine learning and how to process it. Then, what are the algorithms are required for selection and training? Now data is ready, and the process data is ready. Now we need some kind of algorithms to learn that. Which are that? Then they are classified into two ways. They are supervised learning and unsupervised learning. What are the algorithms in supervised learning? Linear classification, classifier, naive Bayes, support vector machines, decision tree, random forest, and k nearest neighbor, and neural network, that is deep learning. What is linear classification? Here the data is going to be in the form of linear data. It classifies, suppose with an example of this array data, it is going to be classified into homogeneity. If it is a cluster data, this linear classifier will not help to classify. And naive Bayes, it is a mixture of that. And support vector machine, it is going to be machine dependent data classifier. And decision tree, it helps you to decide what kind of data falls in what direction. And random forest, it is going to be fix the data, pick the data from randomly in the data sets. And in the k nearest neighbor, this feature of this algorithm is to identify the data with a nearest data classification. And deep learning algorithm, neural networks, will helps you to give more accurate result, especially in the neural networks. It gives more accuracy. So these are all falls in supervised learning, but these algorithms are going to be used for target functioning. Suppose if it is geometric, we need neural networks. If it is linear data classifier, needs a simple classifications. Naive Bayes mixture of classification, like that. See, these different algorithms are used for different target functioning. Then what is the algorithm used for unsupervised? One is PCA, T is SNE, K means, DB scan. These are all the algorithms which is used for unsupervised. Especially unsupervised is the accuracy of unsupervised is very even compared to supervised learning. Unsupervised learning accuracy is less. Why? Because you have already predicted data is there, but here the algorithm itself has to predict and gives result. So the accuracy may be less, but it gives some amount of result based on the unsupervised learning. Then in the reinforcement, we have SARS and Q learning. These two algorithms are going to be used for continuous evaluation of a continuous extracting of data and output based on the reinforcement. Agree with me, all of you? Yeah. come to the algorithm selection and training. We saw in the previous slide, we have a set of algorithms for supervised and set of algorithms for unsupervised and reinforcement. Then how to select these algorithms based on the target function. I told you that how there is a target function. Based on the target function, we can select our algorithms. How to select? Here, goal of training, making the correct prediction as often as possible. Look at this example. Incremental improvement, the predict and adjust. This back propagation, what we can see here. Here, first you predict. If the predict is not up to the mark, then adjust the weights. Then go to predict again. That's what we can call it as back propagation. So for this, you can choose if it is a linear classification, supply the data, predict. If it is not accept, then go to adjust again weights based on this. So the same way, all algorithms will help based on this prediction and adjustment. Then use of metrics for evaluating performance and comparing these solutions. What is use of metrics for evaluating? In the used data set, we can one of the weight is going to be adjusted with the current weight. See, in the used data set, we cannot able to use all the data, compare all the data sets near that the matrix data set. Nearest data, especially in the k-nearest algorithm, what it does, whichever the data which is very nearest to this current data, then it is going to be evaluate the performance. Why it is do? Because it improves the machine performance as well as accuracy. Yeah. Come to the hypermeter tuning. What it does? It more art than the science. Means hyperparameter tuning is just like you are adjusting a weight in the back propagation. It tunes and adjusts the accuracy. If it is not accurate, then again it tunes. When it is going to be start tuning? Once it reaches the target accuracy. So that is what is hyperparameter tuning. I think you know that how to select the algorithm based on the training and selection. And what is this making predictions? How to predict it? By training data phase. Here is the training phase. First you label the data and samples, feature extraction, then features and machine learning model. You finally after training phase, your machine is prepare the model for learning. Then in the production phase, input, feature extraction, then features, a trained classifier. Where this trained classifier is there, that is machine learning model. It extracts from there. Then it gives a label, that is output. Okay, which are the tasks solved by machine learning? Here, recognizing patterns, there are facial identifiers or facial expressions, and handwritten or spoken words, and medical images. You know, this facial identifiers and facial expressions identifying by machine learning is challenging because the facial identifiers are based on the different parameter sets and it differs from person to person faces because in a Indian continent we have facial identifiers are different than the other continents. So why I'm telling this example, the maybe the facial structure and skull formation is same, but the parameters are varies. Some continental your eyes volume is means eye dimension is differ from continent to continent. I think you agree with me. In that case, we have set some target target values for particular object, that is eye parameter. If you take, we set some parameter, but it if it is not matches, your machine learning will fails to accept that. So for that reason only, the facial identification is very much essential, and also it's challenging. And facial expression, especially, I think you know that the different expressions like cry mode and happy mode, then mixed feeling mode, then sad mode. To this sad mode and feeling mode is very much similar, but classifying this sad mode and feeling mode is somewhat very narrow. Then you need to identify very clearly or accurately what is the facial expressions. So for that we need this recognizing patterns. So for that we have to what we have to do, you have to collect more amount of data for different feelings, then train your network. Then only the accurate facial expressions one can expect from this pattern recognition. Agree with me? Next, come to the handwriting and spoken words. Here many research work has happened, especially in the pattern recognition and the handwritten expression in the University of Mysore. And here in the handwriting and spoken words, still the accuracy is not reached more than 95%. Why? Because identifying handwritten is very much difficult than finding a facial expression and facial identifies. Here the handwriting patterns are differ from person to person, that we know, and even place to place and continent to continent. The spoken word somehow we can but the handwritten words are recognizing the patterns are very much difficult. And medical images, here also the pattern recognition is very much challenging, especially in the medical images. And medical images helps to identify the disease in a accurate manner. So to using these kind of data sets, if you give quantitative data and the quality data to the machine learning, definitely we can solve the recognition patterns, especially in these three areas. The next one is generating patterns. How to generate data patterns? By generating images or motion sequences. Especially in the motion sequence, generating a pattern is challenging again. And while applying the data of motion sequence to the machine learning algorithm is somewhat the amount of data is going to be taken more, and even your processing speed also going to be less, because motion sequences are taking more and more space and also processing speed. Example, if you take analyzing a body motion of a bowler in the cricket. So in this case, start from the start point of bowling to the delivery of ball, how many sequences are there? Sometimes it may be 50, 100 or 150 sometimes. Why? Because the fast bowler is having more sequence and the spin bowlers are having less sequences, like that. But while analyzing this, you need to take all these sequences. And if you want to take all these sequences, again the amount of data is going to be increases. If it increases the data of amount, the processing speed is going to be decreases. So while generating a patterns, we must be careful. What is the amount of sequences we need to take? What is the amount of data we need to generate for supplying to the machine learning algorithm? We cannot take all the data for machine learning algorithm. We need to take the data which is necessary. So that generating a pattern will helps you to identify which is the quantity data for collecting the and supplying to the machine learning algorithms. Come to the recognizing anomalies. How to maybe the anomalies comes in a number of directions, a number of times also. Sometimes you cannot expect that anomaly, but it rises. What is the situations? That is unusual credit card transaction. Either it may be tapping, or it may be a fraudulent machines, or it may be a your card issues, or maybe sometime the frauds are going to be happen for your card with your mobile numbers, and it is attached. Many ways are there. Then identifying is somewhat unusual in the credit card anomalies, and unusual patterns for sensor reading in nuclear power plant.
It's okay. నేనే ఫస్ట్ ఎంప్లాయ్ ಆಗమంతంದೆ.
Okay, in the unusual patterns of sensor readings in a nuclear power plant. In a nuclear power plant is one of the most sensitive area where the unusual patterns found immediately it has to rectify and solve this. Otherwise, the entire station is going to be in the trouble. Wherever the sensitive areas are there, the recognizing anomalies and solving is very much essential. That too immediately. Otherwise, it creates a lot of loss and injuries also. So your machine learning system will help you to identify these anomalies and solve immediately, and it protects the property as well as protects the loss also. So come to the predictions. The future stock prices or current currency exchange rates. This especially in the stock market, stock prices are going to be vary every minute or every second, and currency exchange rates are also going to be cannot able to predict that. The market is varies based on the GDP of either in the country GDP or world GDP also. That's what if something goes wrong in Syria or in Ethiopia or Europe, but it directly affects on the stock prices of Indian NSE or BSE. Why? Is any relation between these BSE NSE of India to Syria and Ethiopia? How it relates? How if it is anything goes wrong in Syria, the stock is going to be below in flowing down in the BSE, Bombay Stock Exchange. Why? Because the investors are investing all over the world. Especially if you take oil stock, if anything goes wrong, strike in any of the Gulf countries, immediately the stock prices are going to be increases in the oil sector because of this reason. It is an international market, which something has happened, and immediately you need to predict it, and you need to solve this problem using machine learning. This machine learning will help in all these directions, like recognizing patterns, generating patterns, recognizing anomalies, and prediction, and solve these problems. Agree with me? Yeah, it requires everyday human life. It makes human life simpler. Otherwise, the human get lost because of not able to predict properly. Yes. Okay, now we understand what is machine learning, how it helps to solve the most critical problems. Then how the Internet of Things are going to be solved in this direction, and how we can embed these machine learning concepts in the Internet of Things. Then try to understand now what is Internet of Things first. Things having identifies and virtual personalities operating in a smart spaces using intelligent interfaces to connect and communicate with social, environmental, and user context. For connecting multiple devices in one network, that is called Internet of Things. Here, the social, the environmental, and the user context are going to become together in a one platform, that is Internet of Things, IoT. In the other way, the Internet of Things refers to a vast number of things that are connected to the internet. So they can share data with other things, applications, connected devices, industrial, machine, and more. you take an example of household items today, all household items are interconnected together, and it can be watched by the person by any device, either mobile or a system. Okay, and he can operate these devices. He is sitting in the office and control these household items in the home. So what is the common platform here? The internet is a common platform. These devices are connected to this. Now the question is what? Handling these items by the human intervention is somewhat only Internet of Things with human intervention. But I don't want to the person don't want to intervene these items on his own. Then what is the next option? That is machine learning. The machine, you need to set, you need to give instructions in such a way that, if you take an example, at 6:30, all the electric bulbs should switch off. Either the two ways are there here now. So to switch off these all electrical bulbs in the morning 6:30. How? Either you can connect with your mobile and using this app you can switch off. So every day doing this job is very tedious. Is it so? Then what is the next option? Then you need to create a program, that is machine learning program. So what it does, first it understands what is the time, that is input, that is data. Then what is the output? Once the environmental data is going to be brighter, that is in the morning 6:30, somewhat the light is not necessary in the homes, or else in the other direction, in the hall, if more brightness are there, then you need not. But in the rooms, some less brightness is there, you need. But in the human intervention, what it does, if once you click switch off, all the lights are going to get switch off in the morning hours. But I don't want like that. I need some lights which is there in the hall, which is the hall is not required. I need some lighting in the room. I need some lighting in the washroom and all. Then what? Then you need this machine intervention. So machine identifies the environment using unsupervised learning. Then if it is a more brightness, switch off. If it is less brightness, keep the light on. Is it so? Is it not helpful for the IoT things to handle by machine learning algorithm? That's what today's scenario, and it requires in the today's environment that it has to understand its own, then act according to that. I think agree with me. That's what the Internet of Things embedded with machine learning algorithms. Next is connected devices use built-in sensor to collect the data and in some cases act on it. So what is this built-in sensor? Is a algorithm, machine learning algorithm. The algorithms are going to be embedded with these devices with a built-in sensor. Sensor will sense the data, environment data, that is brightness, and based on the previous training sets, it identifies. Suppose in the morning 6:30, the brightness is somewhat 35%, switch off the light. If the brightness is below 35%, switch on the light. Is it so? If you are given instruction in such a way that the sensors will act according to that. What is the sensor? All these sensors are machine learning algorithms. And collect the data, act according to that. So today we need this kind of scenario for simplify the human life. Then the term, the Internet of Things, was coined by the entrepreneur Kevin Austin. He is a pioneer scientist in this area, where he able to connect multiple devices in one thing, that is one internet, then activate all these devices with Internet of Things. So today the multiple jobs are going to be done in a single click because of this intervention, or because of this inventions that is done by Kevin Austin. from many times, any place, connectivity for anyone, we will now have connectivity for anything. It means that, look at this diagram. Anytime connection, anything connection, and any place connection. In anytime connection, we have on move, outdoor and indoors, night and day time. In the anything connection is between the pieces, human to human, not using pieces, human to human things, using generic equipments, then things to things, that is T to T. Then any place connection is on move, outdoor, indoor, and at any and the PC. By looking this, how simple handling the things in your anywhere, anytime, and any place. It requires actually for today's simplified lives, because people are move around and people, they get connected with each other, and now it is happening. But the thing we are missing is act on its own. Now the solution is machine learning, acts on its own. Okay, in the same example, in on move, I can control my things while on move also. But if you miss that to control the items on move, then automatically it has to give a trigger to the person that these things are going to be happen, and it alerts you. Then it correct the system with the proper direction, and it allows you to not lose any small things which is going to be occur use loss for the person. So your Internet of Things with machine learning is futures for simplifying more and more for the human life. By looking this example, we can identify that how simple the Internet of Things with machine learning helps you the human life. What is machine-to-machine communication? That is M2M, data communication among the physical things which which do not need human intervention or interconnections. How it is possible? Machine-to-machine interconnection. Suppose in a household system, the water flow to the sump, from the sump to the overhead. Is it two devices now? One is the water is available in the sump and the overhead tank is empty. Until that the human interaction part is that once the water is empty in the overhead, what you do? You switch on the motors and the data, the water is flow to the overhead tank, then utilize. But what is it a machine to machine communication? No, it is a machine to human intervention. What is the machine to machine communication? The human intervention will not be there. Automatically, once the sump is going to be empty, overhead tank is going to be empty, your sump machine should activate immediately, and it flows the water to the overhead tank. This is what machine to machine intervention, machine to machine communication. Here, the no human intervention is there. How it is going to be? Because of the sensor again. If the sensor identifies that the water flow is less in the sump, it gives an instruction, it gives a program, or it gives an instruction to the sump motor that you switch on the motor and pump the water to the overhead plant. And when it stops, once there are two sensors there here. One is lower sensor and upper sensor. Lower sensor identifies that empty of water. The upper sensor identifies that full loading of water. Once the water come to the level of loading, then immediately it send an instructions that this water should be pump should be switch off. So automatically it switch off the sump. Now in every most of the houses today in urban areas, they are using this machine to machine communication, especially in the sensor water flow communications system. Is it not helps the human life? Yeah, it makes more simple. Nowhere you will not feel that the empty water is going to be empty in the overhead tank. It fills automatically. This is a simple example I'm taking. Like that, many examples are going to be there for communicate between the machine to machine. The other examples are data communication between things and server, and things to things communication either directly or over a network. These are especially the client server. The thing because server to things are very much essential today, and also it requires. Now in the mobile also, what you do? We now will not deposit our data in the mobile storage. We deposit our data in the cloud storage. But what is the things that too? We'll set our mobile that in such a way that once the data, suppose I click a photo today, and I already given instruction that once the photo clicks, it should be repository in my server, cloud server. What it does, immediately it sends the data to the cloud server. Later, if you want to access, it will not, you can access either anywhere, either your mobile phone or any other devices based on the data which is available, repository in the cloud. Is it not so? See, the things are happened in one device, and accessing is going to be happen in other device in the same location, that is cloud. So this is what about the data communication between the things and the server. So here, how the machine learning helps you? The things, the mobile device is one thing, and the server is another thing, and the PC is another thing. But what is the common thing which connects? The internet. And how the data is given instruction based on the machine learning algorithms, we given instruction in such a way that you send this data to the cloud, then access the data wherever, whenever, and whatever. This is what the data communication. Then things to things communication, either directly or by the network. Okay, the things to things communication is what like connectivity between the mobile phones, and ringing and receiving the calls, or sending data and receiving the data via network. This is what our things to things communication, right? So this is about how machine to machine communication is going to be happen. Here is what the machine to machine communication key elements. What is that? Devices capable of replaying to request for data contained within those devices are capable of transmitting the data automatically or autonomously. Here, the devices in such set such a way that communication between the things are going to be capable to transmit the data autonomously. Automatically, it has to transfer the data by setting of machine learning instructions. If you take a simple example in the banking sector, I instructed the banking algorithm in such a way that so and so date this much amount has to transfer from my account to another account. But even though whether you are knowing or not, you are remembering or not, it is going to be happen automatically every month or every instructions what you do. That's what it is, M2M device communications. Then M2M area network device domain, what is that? Provides connectivity between the M2M devices and M2M gateways. Example, personal area networks. Here, you want to do personal area network, then you set the devices in such a way that communicate between the devices, or else especially in the mobile devices, towers, mobile towers, it does. This best example is area network in the mobile towers. Then come to M2M gateway. Here uses M2M capabilities to ensure M2M devices interworking and interconnection to the communication network. This gateway will helps you to interworking and interconnection. Here, take a same example of mobile tower. In this case, we have multiple networks like Geo network, Bharti Airtel, then Idea, wherever. In the internetworking, the call comes from the Geo network to the Bharti Airtel. It has to pass through two different networks. What is that? It receives the call from the Geo network tower to transmitting the call to the Idea network tower. From the idea network, it identifies the calls and transmit the call to the idea network SIM. This is the way how the gateways are helps you to transmitting the calls from inter-networking. I think you guess it, right? So this is the way how the M2M communication is going to happen in the inter-networking gateway. Then M2M communication networks, which helps in communication between the M2M gateways and M2M applications. Your example is XDSL, LTE, and WiMAX and WLAN. These are the simple example. Today, LTE plays an important role in the mobile communications. Right? Without LTE, your calls are not going to transmit between the gateways. And even WiMAX also, and getting an internet from the multiple sources, it requires WiMAX and LAN network, WLAN required network to transmitting the data. Then finally, applications, that is M2M applications are contains the middleware layer where data goes through various applications services and is used by the specific business process engines. Here, the continuous middleware will helps you to transmitting the data for business process engines. There are three ways are the in the client server technology we have only client and server. In the business process we need a middleware. So it transmitting the data by collecting and processing and sending to the particular target function. That's what it required M2M applications. Then come to the building blocks of IoT. What is the building blocks which requires IoT is end devices, nodes, gateways, local processing nodes, connectivity, cloud-based application, and storage. We need physical devices for Internet of Things, but logical programs for the sensors to handle these devices and gateways. Here, end devices and nodes are going to be physical. Gateways and local processing also hardware devices. In the connectivity is required these algorithms, that IoT algorithms are machine learning algorithms. Then cloud-based application, it combination of both storage as well as connectivity. So look at this scenario, how the IoT application is going to be happen through machine learning algorithms. A smart homes. That's what we give an example of smart home. Respond to the user with a smartphone. Right, in the first case, number one, user with a smartphone enters the room. Excuse me. So the user with smartphone enters the room. What the sensor will do? Second point, you see, occupancy sensor detects his presence and notifies setup box. And in these two cases, which is the IoT things? That is smartphone, which is held with a person, and sensors, which is there in the setup box. These two are the IoT devices. And what is the ML? What is the functionality of ML here by machine learning? It senses the sensor detects how it is detects based on the data which is already reposited. If the person's space or things that in the mobile phone number or a COMI number or what is unique identity number is not recognized by this sensor, then automatically it resets for entering to the house. And if it is matches, then it opens. How it is happened? Because already it is learned that this is the person or a device which is a legal one. Who is decided? The algorithm, the ML decides that because of his previous learning. So now IoT devices and ML devices both put together completes the task that whether identifies whether is a legal person to enter to the home or not. I'll look at the third statement. STB looks for user profile in his mobile devices. If it is matches, then fourth one is STB adjust the temperature and lightening level of according to the environment. If it is not proper for visibility case and all, right? So this is a way how IoT devices and algorithms are put together to complete the task of the smartphone. Which are the major components of IoT? Smart home, sensor technology, communication technology, machine learning, and human machine interface, that is UI and UX. And major components of things are devices, cloud, user interface, analytics, and gateway. So all put together, it is going to be a combination of IoT and machine learning. So this is the final application where uh, human lives are going to be simple and secured. Security must be important, right? So later in the, suppose if the person who holds this device, anybody can enter to the home? No. Why? Because it sends in a both direction, device as well as human face recognition. Then only it is going to be allows you to enter the home. It is a secured one, and recognition of your device as well as home is going to be identified by the IoT devices, right? So this combination all put together, it becomes the complete application, and it gives a simplest solution for security reason as well as communication between the devices. Look at that. What are the features of machine learning with IoT? Machine learning delivers insight hidden in IoT data for rapid, automated responses and improved decision making. So, if independently, if you communicate only IoT devices, it not give much effectiveness. Why? Because it should be a rapid and automated responses required to improve the decision making. Then only it combination of machine learning and IoT gives more accurate result for decision making. Then making machine learning can help demonstrate the hidden patterns in IoT data by analyzing massive volumes of data using sophisticated algorithms. So any sophisticated algorithm we take, it requires to handle this massive volume of data, it requires a sophisticated algorithm. Then with machine learning for IoT, you can do ingest and transform data into consistent formats, building a machine learning model and deploy this machine learning model on cloud and edge devices, edge and wire devices. So these are the major applications of machine learning with IoT. Applying ML to IoT is predictive equipment maintenance in the industry, or predictive capabilities are extremely useful in a industry setting. Today, in the automated industry, either the packing industry or especially in the lathe cutting machine, cutting industry, or lathe preparing industry, everything is automated now. Between the devices is going to be communicates, and especially in the packing device, no much human intervention is there. It all automatic. Automatic machines are going to be packing of your all grocery food products and all. By drawing data from multiple sensors in or on a machines, machine learning algorithm can learn what's typical for a machine and then detects when something abnormal being occur. When abnormal being occur, suppose while if you take an example of packing industry, if you instructed to pack 1 kg of sugar for every packet, and sometimes while initially the human is going to be observed that whether it is going to be packing properly or not. In between that, because of some anomalies, if one kg of less or more sugar is going to be packed, who is going to get responsible? Then automatically your machine should guess or identify the anomaly of exactly 1 kg sugar is packing or not. That is also a sensor continuously sensing that whether the every packet are going to be a uniform or 1 kg sugar is packed or not. That is what the ML the sensor is detects and uh, rectify and remove that anomaly, then it gives an accurate result for packing of this. In the case of sugar packing, 1 kg sugar packing. So this what how machine learning helps you to do communication between the IoTs. Then predicting when a machine needs maintenance is incredibly valuable, and translating into millions of dollars in a saved countries, like saved costs. Especially in the industry of automotive industry, the machine learning intervention of ML is saves millions of dollars in the cost wise. And applying ML in IoT, that is a company called Aguri does exactly this what vibration of ultrasonic sensor installed in the equipment. Then the collect data is sent to the servers where it is compared. In this case, he has installed the ultrasonic sensors. Now it has come even in every car also, ultrasonic sensor. You can identify your car, where it is moving, on what direction it is moving, what is the speed. The speed is moving. All kind of parameters we can identify based on this applying ML into IoT. And data analysis automation is one of the example where when a car is moving, the sensor records thousands of data points which needs to process a real-time, prevent accidents and other offer comfort to the passengers. This is also one of the best example for applying ML to IoT. And applying ML in IoT by shaping experiences to individuals, that is both Amazon and Netflix use machine learning to learn our performance preferences and provide a better experience for the users. That is especially in the today the TV media, Netflix and Amazon plays an important role where you can set your targets, like how much how many months of subscription you need, you can set by machine learning algorithms. This is what about applications. And smart energy, here also you can save your energy based on setting. That's what in the beginning only I told, that when it is required, switch on, when it is not required, switch off. It is going to be identify on its own, so it saves a lot of energy. And intelligent routing, the combination of IoT sensor along with the machine learning algorithm system are used for predicting traffic jams and also making routers to particular destination points. This is called intelligent routing. And the smart home security, already we discussed about this, how the home entering to the home with the right person, right device, and if it is not person, even right device and wrong person, it not allows, and right person not wrong device, it is also not allows. Based on that, the home is going to be a secure one. And the smart energy management, here there are several aspects of energy management that can easily change the improvement, or they are reduce carbon emission and as well as saving money for the utilities. Like that, it is easier to monitor energy usage for heating, lighting, air conditioner, elevators, fire safety system. Like this, a lot of energy saving managements are there. Then health monitoring applications, here also it helps. Machine learning will help apply to data from or variables where learn about baseline and determine when our vitals will have become abnormal, calling a doctor or ambulance automatically is necessary. Now, most of the time for the simple diseases, the patients are going to do self-medication based on these machine learning applications. For the major thing, we are to consult the doctors, like that. Then these are all the many applications what we saw, how machine learning and IoT put together and makes human life simpler. I think agree with all of you. Finally conclude that IoT with the aid of machine learning, it can provide a breakthrough solution for smart energy management system, smart home security, smart retail shop, predictive environment maintenance in industries, intelligent traffic routing, etc. However, you might wonder if they two can successful without each other or not. Well, as one can easily utilize the machine learning system to actually execute tasks on the currently existing data, but at the same time, IoT generates a vast amount of data. So this is how both machine learning and IoT to do wonders. Any questions? Pawan sir?
Hello, sir.
Hello,
Yeah,
sir.
sir. Yeah, so any question, please?
Sir, I'm Professor Shekhar.
Yes, sir.
In banking sector, sir,
Yes,
or
sir.
in apartments, we'll have a layer of 16 cameras.
Okay.
All those things can be monitored on a single monitor, 16
Okay.
frames. How this is different from NMRI scanning? We scan the entire body once or
Okay.
particular portion, but we
Okay.
get output once again 16 frames.
Yeah, sir. Especially the IoT devices, what you have given example with the independent IoT devices. If you apply ML, then your program is going to be creates in such a way that the data which is supplied by the by the machine as well as the output which is given by the alga program, all put
Yes,
together, it identifies that the target object. Your target object is, while doing MRI scanning, you need, for example, if you take a brain image, then you need to scan the entire brain. Out of that, which portion you want, then it decides by the output in a ML. So then in this way, whatever the target object you have decided, that is going to be predicts and gives to you.
Okay, sir. Thank you.
Yes, yes. Especially in the combination of machine learning and IoT, it gives more accuracy because of this reason only. Target function is exactly defined. Yes, any more questions, please?
So one more thing, sir.
Yeah.
Regarding automatic traffic routing in cities.
Yes, sir.
We are training a mission, something driverless car.
Yeah. Today is
specify source and destination. But even in India, places like Bangalore, we see
Any more
every week
queries
routes
from
are changing.
participants?
Weekly.
Okay. Yeah, recently in the Japan, it's happened. I think already it's on the road. You see, I told you that unsupervised learning.
Yeah.
I think you observed that in a before going to this car, it is the same technique applied in airplanes.
Okay.
And while doing the airplane is going to sit in the autopilot mode, unsupervised learning algorithms are going to play important role in this case. Right. So once the flight is in autopilot mode, if anything wrong objects come towards the flight, it try to avoid or it attacks. Both is going to be do by the flight. The same way in automated car system, like a driverless car system, it applies the ML technique of unsupervised learning. What it does, this unsupervised learning, it understands the environmental parameters.
Okay.
Based on the environmental parameters, it acts according to that.
Okay.
This is the way how your automated driverless car is going to be performs. But what your question is, the busy areas like in Bangalore, is it possible right now?
Yeah. Traffic is changing.
Yeah. See, even it is possible, but the algorithms are going to be trained in such a way that the more amount of traffic, like 2 years data, 3 years data, you need to train the network. Then you can apply this algorithm to the machine learning devices, that is IoT device like car. Then you can try, sir. It is possible. Shortly, it is going to be happen even in Bangalore also, as per the predictions.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you. Yeah. Any more questions, please?
Yeah.
Pawan, sir.
Thank you, Professor. Thank you, Professor K. Shekhar, asking a very nice question, and hope you got the satisfied answer from the eminent resource person. And any more participants? One or two participants can have any questions. Please raise the queries. I think the participants are not raising any queries here. So hope so they are learned the things in the morning session. So in the afternoon, again sharp 2 o'clock, and you can join with the same link, Zoom link,
Yes,
and
sir.
feedback
Okay.
form will be shared in the afternoon.
Yes.
Thank you, Dr. K. Tippeswamy and Professor of VTU. Thank you very much, and we will go for the demonstration in the afternoon. Thank you very much, sir.
Okay, sir. And I thank all the participants for patience listening. And I hope
Session.
you understand the concepts of ML with IoT in a proper direction. And at the same time, I thank Dr. Pawan giving an opportunity, and also SITAMS Engineering College, AICTE, and VTU for providing an opportunity to speak a few words in this beautiful occasion. Thank you, Ananda.
Thank you, sir.
So, can I leave, sir, now?
Yes, sir. Yes, sir.
Okay, at 2 o'clock, I'm going to join again.
Thank you, sir.
Okay, see you, sir. Thank you.